What are the odds? On October 29th, Atlas reached perihelion, the closest point to our Sun at 203 million kilometers. For 6 days, from October 24th to today, it's been hidden behind the Sun, completely invisible to every telescope on Earth. We couldn't observe the most critical moment of its journey through our solar system. But here's what nobody expected. We're not actually blind. ESA's JUICE spacecraft, currently on its 8-year journey to Jupiter, just happens to be in the perfect position to observe Atlas right now. And the timing is so extraordinary, so statistically improbable, that scientists at the Max Planck Institute are calling it an unexpected stroke of luck. Let me tell you why this matters, and why the next few weeks could change everything. JUICE launched in April 2023, over 2 years ago, on a mission to study Jupiter's moons. It's traveling through deep space on a carefully calculated trajectory. Atlas was discovered just 4 months ago, on July 1st, 2025, an interstellar visitor from beyond our solar system moving at 220,000 kilometers per hour on a completely different path. The fact that these two objects are encountering each other right now, at this exact moment in space, while Earth is on the wrong side of the Sun, is extraordinary cosmic timing. Ladislav Razak, MPS scientist and project lead for JUICE's instruments, said it perfectly. We never expected anything like this. And here's why this is so critical. Remember the test we've been waiting for? The massive gas cloud that should exist if Atlas's non-gravitational acceleration is natural? JUICE is about to measure it. Right now, JUICE is only 60 million kilometers from Atlas. That's incredibly close by space standards, and it's equipped with instruments specifically designed to detect exactly what we need to see: water sublimation and gas production. JUICE's submillimeter wave instrument, SWI, can detect water molecules with extreme precision. It can measure whether water is sublimating from Atlas's surface, how much is being released, and whether it's coming from the nucleus itself or from ice grains in the surrounding coma. Current measurements show Atlas is producing about 2 tons of water vapor per second. Let me put that in perspective. If Atlas lost 1/6 of its mass during perihelion, as calculations suggest, that's 5.5 billion tons total. 2 tons per second sounds like a lot, but over the perihelion month, that's only about 5 million tons. We need to see over 1,000 times more material than what's currently being detected. JUICE's particle environment package, PEP, will measure energetic neutral atoms created when solar wind collides with gas around Atlas. The more gas Atlas releases, the more particles PEP will detect. This tells us directly how much material is being ejected into space. These measurements answer the fundamental question: is there a massive debris cloud consistent with losing 1/6 of Atlas's mass, or isn't there? But here's where it gets operationally complex. JUICE can only look directly at Atlas for 30 minutes per day. Why? Because pointing toward Atlas means exposing sensitive instruments to solar radiation. The spacecraft has to carefully balance observation time with protecting its equipment. Additionally, JUICE and Atlas are traveling in opposite directions at combined speeds exceeding 300,000 kilometers per hour. The observation window is narrow, fleeting, and will never happen again. JUICE's observation campaign runs from November 2nd through November 25th. 3 weeks to capture data that could answer whether we're looking at an exotic natural comet or something artificial. This is humanity's only close-up view of Atlas during this critical post-perihelion period. There are no other spacecraft positioned to observe it. Earth-based telescopes are blocked by the Sun. This is it. And the implications are enormous. If JUICE detects massive water sublimation, huge quantities of gas and dust, then the natural explanation holds. Atlas is an unusual but fundamentally natural object from another stellar system. But if JUICE's measurements show modest outgassing, if the debris cloud isn't nearly massive enough to explain the non-gravitational acceleration, then we have confirmation that something else is pushing Atlas, something artificial. Now here's the frustrating part. NASA captured the highest resolution images of Atlas ever taken on October 2nd with the HiRISE camera aboard Mars Reconnaissance Orbiter. Those images are 3 times better than Hubble. They could show us exactly what Atlas looks like, whether there are structures, whether it's fragmenting, what's really happening. But NASA still hasn't released them. Despite requests from Avi Loeb, despite an official letter from Congresswoman Anna Paulina Luna, the images remain classified or withheld. So now the question becomes, will ESA release JUICE's data? Will we get transparency from the European Space Agency where we haven't from NASA? This is the big question. We have a spacecraft perfectly positioned, capturing unprecedented measurements during the exact window when we need them most. Will we get to see what JUICE observes? The cosmic timing that put JUICE in position to observe Atlas is 1 in a million. A spacecraft launched 2 years ago, an interstellar object discovered 4 months ago, both arriving at the same region of space at the exact moment when Earth cannot observe. If you believe in coincidence, this is the ultimate coincidence. If you don't, well, that's an even more interesting conversation. The observation campaign is happening now. JUICE is measuring. Data is being collected. And soon, we'll see if the authorities release what they find, or if this becomes another mystery of withheld information. Stay tuned, because the cosmic lottery just gave us front row seats to the most important observation in interstellar object science. And we're about to find out if transparency wins or if secrecy prevails once again.